Hello students, welcome to another video of number theory. Today we are going to discuss some examples. First example, find the Legendre symbol. We are going to discuss examples on the previous topic, that is quadratic reciprocity law and the theorem before that. So first example is find Legendre symbol of 13 and 5. Now we are going to solve this example by using quadratic reciprocity law and the theorem of minus 1 raised to n, where n is of the form this summation j running from 1 to p minus 1 by 2 j by greatest integer function of j by p. So first of all we are going to solve this by quadratic reciprocity law. Here we are going to use the quadratic reciprocity law if the p and q, that is both the numbers are prime numbers, then and only then we are going to use that quadratic reciprocity law. Here p is equals to 13 and q is equals to 5. Therefore by using quadratic reciprocity law, we can write the Legendre symbol of 5 and 13 into Legendre symbol of Legendre symbol of 13 and 5 into Legendre symbol of 5 and 13 is equals to minus 1 raised to p minus 1 by 2, that is 13 minus 1 by 2 into q minus 1 by 2 is 5 minus 1 by 2, which equals minus 1 raised to this 13 minus 1 12 by 2 is 6 into 5 minus 1 is 4 by 2 is 2. So 6 into 2 is 12, which is equals to minus 1 raised to 12 is plus 1. So we get Legendre symbol of 13 and 5 into Legendre symbol of 5 and 13 is equals to 1, but we are willing to find the Legendre symbol of 13 and 5. Now we have to find the Legendre symbol of 5 and 13. So to find Legendre symbol of 5 and 13, we can use the first property that we have seen at the start of our chapter. So Legendre symbol of a and p is equals to p raised to a raised to p minus 1 by 2 under modulo p, but Legendre symbol of 5 and 13 is equals to 5, which is congruent to 5 raised to p, that is 13 minus 1 by 2 under modulo p, that is 13. This is by property number first. So which is congruent to 5 to the power 13 minus 1 12 by 2 is 6, 5 raised to 6 under modulo 13. So instead of this 6, 5 square to the power 3 under modulo 13, since 3 to the 6. So 5 square is 25 and 25 under modulo 13 is congruent to 25, means 13 to the 26 minus 1. 5 square 25 is congruent to minus 1 under modulo 13. So minus 1 cube under modulo 13, and we know that minus 1 cube is minus 1. Therefore Legendre symbol of 5 and 13 is equals to minus 1. Now by putting the Legendre symbol of 5 and 13 in this equation number star, we will get, therefore equation star becomes Legendre symbol of 13 and 5 into minus 1 is equals to 1. So multiplying both sides by minus 1, we will get Legendre symbol of 5 and 13 is equals to minus 1. Now this is the solution by quadratic reciprocity law, or another solution is by using by using the theorem that we have seen earlier. So to use that theorem, that is the theorem of Legendre symbol of a by p is equals to minus 1 raised to n, and where n is of the form summation j running from 1 to p minus 1 by 2 greatest integer function of j by p. So to use that theorem, here first of all we must have the GCD of a and twice p is equals to 1. Here a is equals to 13 and p is equals to 5. Therefore GCD of a and twice p is equals to 13 and twice p is 10, and GCD of 13 and 10 is 1. Therefore we will find the set of integers similar as Gauss lemma, set of integers a twice a up to p minus 1 by 2 times a. So, here p minus 1 by 2 is 2. So, set of integers a and twice a, which is equals to 13 and 26. Now, we are going to find this number, we are going to take these numbers under modulo p. So, 13 is congruent to some number under modulo 13, yes 13, p is equals to 5. So, this 13 is congruent to something under modulo 5. We are going to take these numbers under modulo p, and this 26 is, this 13 is congruent to 3 under modulo 5, and 26 is congruent to 1 under modulo 5. Now, we are going to find the number of residues that exceeds p by 2. P by 2 is 2.5 and 3 is the only residue that exceeds p by 2. Therefore, the number of residues exceeding p by 2, which is equals to 2.5, is 1. Only one residue exceeds p by 2. Therefore, n is equals to 1. Therefore, n is equals to 1. So, by using Gauss lemma, we can show that Legendre symbol of 13 and 5 is equals to minus 1 to the power 1, which is equals to minus 1. Now, similarly, just using Gauss lemma, we will show this, because if we take the Legendre symbol of 13 and 5 is equals to summation j minus 1 raised to n, where n is equals to summation j running from 1 to p minus 1 by 2. So, summation j running from 1 to p minus 1 by 2 is, here p minus 1 by 2 is 2. So, if we run the summation from, this is the just rough work, if we take the Legendre symbol of 13 and 5 is equals to minus 1 raised to n, and where n is of the form summation j running from 1 to p minus 1 by 2 Legendre symbol of j by p, then we will get this summation as, if we put j is equals to 1, then j a by 2, that is 1 a, 13 by p is 5 plus then 26 by 5. 13 by 5 is, characteristic of function of 13 by 5 is 2 point something. So, 2 plus this 5. So, 7, this summation becomes 7. So, if we put again the value of n is equals to 7, then we will get 13 by 5 is equals to minus 1 raised to 7, which is equals to minus 1. So, similarly, using Gauss lemma, we get the Legendre symbol as minus 1. Using quadratic reciprocity law, we will get the Legendre symbol of 13 and 5 is equals to minus 1, and if we use the theorem, that is summation of j running from 1 to p minus 1 by 2, greatest integer function of j and p, j by p is again minus 1. You can use any of these methods, or directly you can use the result of property first, that is 13 raised to p minus 1 by 2 under modulo p, that is 13 raised to 5 minus 1 by 2 under modulo 5, or any of those properties that we have discussed in the first theorem of this chapter. Now, similarly, we are going to prove the second example. The second example is again find the Legendre symbol of both 7 and 13. 7 and 13. Here again both the numbers are prime numbers, so we can use the quadratic reciprocity law. So, here p is equals to 7 and q is equals to 13. Therefore, by quadratic reciprocity law, we can write the Legendre symbol of 7 and 13 into Legendre symbol of 13 and 7 is equals to minus 1 raised to p minus 1 by 2, that is 7 minus 1 by 2 into q minus 1 by 2, that is 13 minus 1 by 2, which is equals to minus 1 raised to 7 minus 1 is 6, 6 by 2 is 3 into 13 minus 1 is 12, 12 by 2 is 6. So, 6 3s are 18, which is equals to minus 1 to the power 18 is equals to plus 1. Now, we have to find this Legendre symbol of 13 and 7, but the Legendre symbol of 13 and 7 is equals to, we can write it as Legendre symbol of 6 by 7, since 13 is congruent to 6 under modulo 7. If A is congruent to B mod P, then Legendre symbol of AP is equals to Legendre symbol of B and P. So, to find the Legendre symbol of 6 and 7, just use the second result, Legendre symbol of 2 by 7 and Legendre symbol of 3 by 7, since Legendre symbol of AB with P is equals to Legendre symbol of A with P into Legendre symbol of B with P. Now, we know that Legendre symbol of 2 and P is equals to, or we can use the first property, that is 2 raised to A raised to P minus 1 by 2, that is 7 minus 1 by 2 under, and again this 3 raised to 7 minus 1 by 2 under modulo 7 by property number 1. So, which is, this is congruent to, again this is congruent to 2 raised to 7 minus 1 6 by 2 3, 2 cube into 3 cube under modulo 7, 2 cube is 8, which is congruent to 1 under modulo 7, 3 cube is 27 and 27 is congruent to minus 1 under modulo 7. So, minus 1 into 1 is minus 1, therefore, Legendre symbol of 13 and 7 is equals to minus 1. Therefore, this equation number star becomes, equation star becomes Legendre symbol of 7 and 13 is equals to 1 into minus 1 is minus 1. Hence, the solution of this example by using quadratic reciprocity law. Same example we can solve by using Gauss lemma or by using this theorem of the summation, and directly by using the any of that 5 properties. Now, next example that we are going to solve. So, before that, take some examples that you can try at home. So, first example is find the Legendre symbol of, first homework 12 and 5. Second, suppose minus 7 and 13. Similarly, the previous example. Now, minus 42 and 31. These are for your homework. Now, next example. So, next example is check whether the congruence check whether the congruence x square is congruent to, check this congruence x square is congruent to 2 modulo 61, 2 modulo 61 has solution or not. This congruence has solution. Check whether the following congruence has solution. First congruence is x square is congruent to 2 mod 61. To find the solution of this congruence, that is to check whether this congruence has solution or not, we must remind the definition of Legendre symbol. Legendre symbol of A and P states that is equals to 1 or minus 1 or 0, depends on either P divides A, P does not divide A, then if PD doesn't divide, say, then this congruence we doesn't check for the solution of any congruence. If P doesn't divides A, then there are two possibilities of Legendre symbol of A and P, which first one is 1 whenever this congruence has solution, and second one is -1 if this congruence has no solution. Now to check the congruence of this, now to check the solution of this congruence, we must find the Legendre symbol of this A and P. If this A and P has solution, if this Legendre symbol of A and P is equals to 1, then we will say that this congruence has solution. If the Legendre symbol of A and P is equals to -1, then we will say that the Legendre, that is, this congruence has no solution. Now to solve these problems, such problems, we just find the Legendre symbol of this A and this P. So here A is equals to 2 and P is equals to 61. Therefore, to find the Legendre symbol of A and P, that is the Legendre symbol of 2 and 61, till now we have lot of methods to solve, that is either 3 or 4, maybe more than that methods to solve the Legendre symbol, to find the Legendre symbol. So in between those I will just use, since here A is equals to 2, which is very small number, so I will use the first property, that is Legendre symbol of 2 and 61 is equals to A, and Legendre symbol of A and P is equals to A raised to P minus 1 by 2, that is 61 minus 1 by 2 under modulo 61. So which is equals to 61 minus 1 is 60 by 2 is 30. So 2 raised to 30 under modulo 61. Now 2 raised to 30 is a very large number. So instead of this, we can use the result Legendre symbol of 2 and P is equals to minus 1 raised to P square minus 1 by 8 under modulo P, or we can just simplify this result. 2 square is 4, 2 cube is 8, 2 raised to 4 is 2 raised to 5 is 32, then 2 raised to 6 is 64, that is 2 raised to 6 into 5 under modulo 61. So if we calculate this will take more step and more time. Instead of, we can use just this solution. We know that the Legendre symbol of 2 and P is equals to minus 1 raised to P square minus 1 by 8 under modulo P. So using this result, we will just minus 1 raised to P square. So 61 is prime number, 61 square. So 61 into 61, 61 into 61 is 1. So I think that will be 73721 and minus 1 by 8 under modulo 61. This number is larger number, but the calculator is allowed for you for the examination. So you can find the number, that this square easily, or using any trick, that is, if the trick of find the squares of any number, if unit place is 1, then that 1, then using the further that trick, you will get 3721 minus 1 by 8. So 3721 minus 1 is 3720 and 3720 by 8. 3720 by 8 is just the number. So this minus 1 raised to 3720 by 8 under modulo 61. So 3720 by 8 is just the number 1, then 1 6, 8 is 16, then again 1, so 6 0, then again by dividing by 2 we will get 930, and again by 2 we will get this 4, then 6 5, 465. So this will congruent under minus 1 raised to 465 under modulo 61 and minus 1 raised to 465, 65 is odd number, so which will congruent to minus 1 under modulo 61. So Legendre symbol of 2 and 61 will be minus 1. So this congruence, therefore we will say that this congruence has no solution, or we just continue our solution. We will prove this, which is congruent. 2 raised to 6 is 64, and 64 is congruent to 3 under modulo 61. So 3 raised to 5 under modulo 61. Now 3 raised to 5, 3 square is 9, 3 cube is 27. So just 3 cube into 3 square will become 3 raised to 5 under modulo 61, or just raise the power of 3 by 5, you will get the answer. So 3 raised to 3 cube is 27. So 27 3s are 60, 81, and 81 is congruent to 20, and then 3, 23 is 60, 60 is congruent to this 3 raised to instead of this I will write this under modulo 61, and this 3 raised to 4 is congruent to 81, and into this 3 under modulo 61, and 83 is congruent to 81 is congruent to 20 into 3 is 60, and 60 is congruent to minus 1 under modulo 61. This calculation is lengthy because I do not have calculator right now. So you can use the calc and just take this congruence under modulo 61, you will get the answer. So Legendre symbol of 2 and 61 is equals to minus 1. So from this we will say that the congruence x square is congruent to 2 modulo 61 has no solution, hence the solution of this example. Now the next example is, that is, let P be a prime such that GCD of A and P is equals to 1, which is equals to GCD of B and P, that is GCD of AP and GCD of BP is equals to 1 if the congruence x square is congruent to A mod P and x square is congruent to B mod P are not solvable, that is this both congruence has no solution, both are not solvable, then prove that x square is congruent to AB under modulo P, then prove that this congruence x square is congruent to AB mod P is solvable. So in this example we have given that P is prime number, also GCD of A and P, GCD of B and P is equals to 1, that is A is relatively prime to B, P and B is again relatively prime to P. Also we have given both these congruences has no solution, and we have to prove that x square is congruent to AB under modulo P is solvable, or that congruence has solution. We have given GCD of A and P, also GCD of B and P is equals to 1, also x square is congruent to A mod P and x square is congruent to B mod P, both are not solvable, that is these both congruences has no solution. So if this congruence has no solution, by using the definition of Legendre symbol, you can say that the Legendre symbol of A and P is equals to, this congruence has no solution means this Legendre symbol is minus 1. Also this Legendre symbol of B and P is also minus 1. So Legendre symbol of A and P is equals to minus 1, Legendre symbol of B and P is equals to minus 1, but we know that Legendre symbol of AB with P is equals to Legendre symbol of A with P into Legendre symbol of B with P. Therefore, so using this, suppose this is the equation number star, or using Legendre symbol of A and P in B and P here, you will get minus 1 into minus 1, and minus 1 into minus 1 is 1. So Legendre symbol of AB with P is equals to minus 1 will give us x square is congruent to this AB under modulo P has solution, or this x square is congruent to AB under modulo P is solvable. Hence the solution. This question may be asked for 2 marks in the university examination.